Hello and welcome to another episode of 2x2. This is your co-host Praveen and I'm joined by my other co-host who is...
Rahel, hi.
Hi, okay. Welcome to 2x2 first of all, but you have to first start by telling us who is not here.
I mean, I'm sure every loyal 2x2 listener has realized already that Rohin is not in the room with us today.
So this is going to be a fantastic and a phenomenal episode. We say this every episode, but this episode is actually going to be fantastic and phenomenal. Why? Why, Rahel?
Well, we are talking about something that has been spoken about a little bit in the past, but, well, we haven't really got clear answers on. What happens to the software engineer, specifically the entry-level software engineer? So someone starting out, how can they really think about the first 5 years of their career?
Yeah, that is true. That is one of the reasons why it is a fantastic episode. But I think the other reason it's going to be a fantastic episode is because Rohin is not here, so we can all speak.
Well,
okay,
I
there will
can't
be
say
enough
that.
people talking. All of us are going to talk and we're going to have our
Let me put this on the record. PGK said that, I didn't.
Of course I did. Okay. No, but I'll just step back and I'll essentially say what's really happening right now. What's happening right now is just last week, Anthropic put out a post and announcement saying that 100% of the code that they have written or they're writing in their tech is now written by AI. Multiple companies are coming forward. Sometime back, around 2 years back, 1 year back, that percentage has been increasing. And different people kept making those claims. In fact, some of them we kind of rubbished as well, where we said, well, who's going to, look at the percentage of your code that's written using AI? But now it looks like, especially over the last 2 months, something big has changed. The train has started going faster and faster. And things are really real right now. And especially on the engineering side, if you look at what Claude has done, if you look at what Codex has done, if you look at what GitHub Copilot has done, all of which we talk about in our other podcast, Zero Shot, we can see that there is no single profession right now that is at the heart and at the eye of the hurricane of AI than software engineering. We actually discussed this in one of our early 2x2 episodes, which we called Is the Golden Era of Software Engineer Over? Where we had Kailash and Amod. And at that point in time, it was a little more structural, a little more high. It was about, okay, we are going to talk about all the various things that are happening to software engineers. Are the high salaries gone? All of that is great, and that's a great episode. You should listen to it. But today's episode is much more urgent, much more present, and critical. So today we are going to have 2 guests to talk about this. My first guest is a returning guest. Welcome, Arnav Gupta, at the rate of champion swimmer on X, formerly Twitter. Arnav, as some of our listeners will know, was there in an earlier episode where we discussed Swiggy. And Arnav is one of the head of engineering at Meta and has had senior engineering positions at companies like Viacom 18, Zomato, and Scalar. So, Arnav, welcome to 2x2.
Hey, hi. Happy to be back.
Yeah, you've been writing a lot about LLMs and coding. If I had to ask you, like in just a few sentences,
Yeah.
what the hell is going on?
I think we'll discuss more through the episode. And I think that everything is changing and yet a lot of things are staying the same. So we'll we'll cover that. Yes. There's a lot to worry about. And I think there's also not a lot to worry about in that sense.
Okay, we'll talk about what is changing and what is staying the same, specifically for software engineers who are just starting up and even for managers of engineers and developers and trying to figure out, okay, what do we do now? What do we not do now? My second guest is Abhay Saraf. Abhay is an entrepreneur and he has established this company called Bushel Technologies based in Nagpur, which is 100% export-oriented software development company. And so Abhay basically does projects for like a ton of clients in the US. He's an ex-Microsoft person. And I have also been I mean, I also had the good fortune of knowing Abhay for like a long time, almost like 25 years. He and I went to college together. And Abhay and I've had these conversations about software engineering and what's been happening to careers. And this has been going on for a while. So I thought that finally, when we're doing an episode about software engineers and what's happening to careers, it's time to get Abhay in. Abhay, welcome to 2x2.
Well, thank you for having me.
I know that you come from a long line of entrepreneurs. Tell us a little bit about what Bushel Technologies does.
As you saw, right, when I left Microsoft and I wanted to do something on my own, and this is akin to what we're going to talk about today, right, which is what I called K-shaped career paths going forward, right, where you have two different curves. One curve is where you have highly trained people who know engineering from apprenticeship at places like Meta, Facebook, the great tech companies of the world. And then there's a mass of software developers who come out of schools not very well trained, etc. And they have difficulty in getting the right training because they are working for a lot of small companies and medium-sized companies which have not invested in individual developments.
Nice.
And I think that K-shaped curve is how I would even look at the impact of AI. Like there'll be a bunch of people who will benefit hugely from it, and there'll be a lot of people whose careers might end. So it's like two different curves coming out of from this output.
Okay. We'll get to the careers of software engineers, but I think I have a question first. I just want to step back and ask both of you, Arnav and Abhay, for some of our listeners who are kind of like on the periphery and looking at this. What is happening with, if I asked you to like step back and say, what is AI really doing to engineering as a function, right? If I asked you to like give us your point of view on what is happening like historically and what happened over the last few weeks and months, like where are we right now? What's going on?
I can take a stab at that. So I think the history is easy to chart from the fact that like what do the LLM still majorly do, and like today AI is a lot of things, but LLM is like where everybody's focusing. Like today when people talk about AI, they're not talking about like the computer playing a FIFA game against you, which was also AI at one point. And like when we talk about AI, we're talking about LLMs, and they're good at generating text. And it was more about like you write half of a paragraph and then the AI completes the rest of it. That's where it started from. But then like people soon discovered that code is also text, and like if I write half of a function and can the AI finish it. And in the last I think 2-3 years there's been a tremendous amount of training of these LLMs on these kind of problem set, because like I think the big labs like DeepMind and Anthropic and OpenAI and I think they all looked at the market and they figured that okay, how much money does a software engineer earn versus how much money does somebody writing a blog earn, and you know there's a multi-trillion-dollar market to chase for writing code than writing just text.
That's true. Journalists don't make money, so no point try to replace journalists. But software engineers, okay. Sorry, go on.
Exactly. So and I like the training curve kind of chased that space, and now they can generate not just like you write half of a piece of code and it generates the rest. It can also do things like where you can ask the AI that okay, I want to add this feature. Not very different from how like a product manager comes to a team of engineering and says that okay, you add this feature, like I want tasks to be assigned to 2 people instead of 1 person, and you just tell this much to the LLM rather than writing code, and it actually generates the code, and that feature gets added. So we are kind of at that stage right now. And I think what that means is today a lot of software engineers, like even when I ask at work and I ask my friends and everybody's like, at least it's been a 1 month or 2 months now that I have not written code by hand. What they basically mean is like they generally, instead of opening up their IDE and you know like typing like int main and function and like that, instead of doing that, what they type is in the chat box and they ask the AI to write the code, and the AI writes it, and they read it and it looks good to them and they merge that code. So that's where we are right now.
Saraf, what's your read on where we are right now?
So software engineering has always gone through this evolution of tools being made available. The real question is whether this current generation of next level languages, AI, LLMs. And AI is a generic word. LLM is, as Arnav is talking about, is more specific, because back in 90s, spell checker was an AI. Nobody calls spell checker as AI today, right? If you go back and read marketing of Microsoft Word, oh, we have artificial intelligence. We can correct your grammar. We can correct your spelling. And that was AI back then. And it's very, there's a notion of humans adopting to new technologies very, very quickly, right? And it becomes par for the course, right? That's like the minimum. Everybody has the same thing, so it doesn't matter. So what I like to look at is, what's a software engineer, right? It's a person who is responsible for translating a real world problem, physical world problem, into a mathematical problem, and then instructing the machine to do something. So even with AILM, do I expect my mother, my grandmother to come in and become prompt engineers? I don't think so, right? We are still going to have all these people who will understand the technology and the complexity and what's the right thing to do, what's the wrong thing to do, and then handle that. And I think it's evolution. The major question in my mind is whether we are getting a 30% productivity boost with LLMs or whether it's a 300% boost with LLM. That's the open question in my mind.
So I have a question. PGK, in fact, earlier on spoke about the note from Anthropic. In fact, the CEO of Anthropic at Davos just recently said that in the next 6 to 12 months, so that's this year, probably around summer, most, if not all, of the end-to-end tasks currently handled by software engineers will be taken care of by AI. So are we saying that the role of a software engineer, like you said, Abhay, is then just a very technically sound prompt engineer? Like, is that what it becomes?
I don't think so. Yeah, when people are selling their tools, they are going to predict a lot of change in the world, right? That's natural, right? I'm the CEO of my company. I'm always trying to sell how good we are, and that's what I expect every single LLM builder to do out there. That's their job, right? I wouldn't question, like, there's a genuine reason for that. Also, you have to look at the people building, right? These are people who are super smart, and they are able to work with tools in a very different manner from most of the world does, right? So the way they operate with these tools is very, very different with the way how the world works, right? I'll give a common example, right? I've talked about this evolution of languages, right? We are at 4th generation or 5th generation of languages, but most of the critical infrastructure like airline booking systems, banking systems are still using languages and systems from 90s, right? Because you want these people to be super conservative in how they change. So yes, if you're writing a new app, you are going to end up using AI, LLM tools and maybe write something. But has it taken care of every edge case which you need when you're flying an airplane, when you're launching a spaceship, when you're dealing with very, very super critical things where human lives are involved? It's an open question whether the society will allow it to be done.
Question for both of you, Arnav and Abhay. Because Abhay, it seems like from all the stuff that you've said so far, you're sort of saying that this is along a continuum. Like, in the sense that there was always abstraction happening. Like at some point, I mean, we weren't human beings weren't necessarily coding in zeros and ones. They weren't typing zeros, but they were very close to that. And then it became little more abstracted, and now you have come to the point where you practically are telling a machine, okay, do this, and it sort of like does the code behind it, right? So you're saying it's along a continuum, and we're just going along that continuum. And Arnav, you also said, very broadly speaking, that like LLMs have started to reach this point where you're doing. I think the part that I'm pushing back against is this, I feel like it's a step order jump. It's way more than a regular linear jump. There is something fundamentally big that has like changed over here. Do you agree with that characterization? Just as an example, by the way, I know both of you follow Kailash Nath, who's the CTO of Zerodha. We did an event at the Ken last year on product building in the age of AI, and he was one of the panelists there. I think I'll just say that during that event, for the large part, Kailash was like, I wouldn't say he was very skeptical about AI, but he was also like, look, I get AI has its use cases in the engineering side, but we will never, I mean, if I remember correctly, he said, we will never ask an AI to like write code. It's almost like a co-pilot kind of a thing. It's around us. We will use it to like do some stuff. But now, Arnav, you're saying, well, it's like, yeah, right.
I mean, he himself has written a blog post
exactly. That's
3 days
coming
back
to.
saying.
Exactly. So 3 days back, Kailash has written on his wonderful, wonderful blog. Okay. And the title is code is cheap, show me the talk, and here is the strap. The strap is software development as it has been done for decades is over. LLM coding tools have changed it fundamentally for the better or for the worse. I think what he's really saying is that, yeah, this is different. This time, something big has changed, and all the traditional things that we have done with like coding has absolutely changed.
Yeah, so I mean, it is like the journey has been transformative. Like I have been also writing code for like 15 years now. I think that big and small, all sorts of changes keep happening, and there have been big changes also in the past. And I think that when people went from having to know, say, assembly language, and when I say having to know, I mean the era when assembly language was the mainstay in which people were coding, to the point where you had some bit of assemblers around, and compilers were starting to grow, but you still required people in your, like, in a software engineering team. You still required the expertise of knowing assembly language. Even a few years after the transition had kind of happened, because the assemblers were not that good. You generate the code and then you still want to optimize the assembly by hand sometimes to get the optimum
By the
performance.
way, I just want to tell Rahel, who's like the only non-engineer here, that this wasn't such a long time ago, right? Around the time when I was doing engineering, we had this 8080 microprocessor, which wasn't assembly, or it was like one step just above assembly, where you'd basically be like, move from control bit to this bit. You're literally like typing it out like almost like one step above a calculator.
Correct,
Thank
correct.
God for Claude Code, am I right?
And like when I was in college, and I actually had a course on assembly as well. I think still today, like 2025 also, like if you are in at least in electronics, you will still learn assembly as coursework in many undergrad degrees as well, right? So that's kind of thought of as a relic of the past now. Instead of asking the LLM to write text, I can ask it to write some React code and it can create a button. Was actually in 2020. It was a post by somebody in July of 2020, and that time ChatGPT had published GPT-3 as a research thing. It was not for coding. There were no, like, it would not even highlight the code it generates. Like today, when you go to one of these like ChatGPT and you ask it to write code instead of writing a document, the part it writes as code automatically becomes like a box, like an IDE, because inherently they know that a lot of people use it for generating code. So the systems are designed like that. Back then it was not like that. It was just generating it like plain text. So people are copying it, pasting it into actually an IDE, and then like, hey, see, it can actually write React, and this because it is text. And 6 years, right? Almost going to be 6 years now when that happened. And we think that it has gone very fast. We think, oh, last 2 months everything has changed. But then when we first discovered that LLMs can be used to write code was actually, say 6 years back. And it was generating fairly correct React code. It could generate a to-do list and a button and all of these things. So it will change. Like looking at that, if this change required 6 years, I'm sure another 3 years, probably another 5 years, knowing how to write JavaScript, knowing how to write Python, knowing how to write Java, it's not going to get erased. Longer term than that, 10 years, I don't know. Like maybe there's going to be at least a class of software where you store the prompts, you store the PRDs, the product documents. You don't actually store the code anymore. Software could be fluid like that. But yeah, let's see where it goes.
If I ask the two of you, because you've had some experience, and Rahel, I think you have also had a podcast on careers called 90,000 Hours, where you had like episodes on, IT services, software engineering careers, etc. Broadly, if I asked you to like kind of break up, because I'm now getting into the software engineer itself, what are the skills that a software engineer needs in the first? We can at least start with entry level for now. Maybe like higher level, it requires things like, oh, you need the ability to manage people, etc. But if I asked you to like break it up, because at one point in time, it was all about code. I mean, very famously, people like Mark Andreessen and others were like, learn to code, make sure your 4-year-old child also knows how to code. Now, we don't know if that's going to be true. But I'm just saying that, what are the skills if I asked you to break it up?
In fact, PGK, if I could chime in there, multiple CTOs that I spoke to and like founders as well of mid-sized startups told me that they've entirely stopped hiring freshers completely. So I think it is a pretty fundamental question of how are you valuable, right, as a young engineer today? Because so many people said that in fact, one person I spoke to at a fintech firm said that 80% of certain teams were freshers, and now that number's it's zero. They don't hire at all. So how do you how are you valuable as an entry level engineer, I guess?
So one of the first things I always, when I'm talking to people in college, is I ask them, why are you in an engineering college? Why are you in an engineering setup? Why is computer science not a part of, say, maths department, or it's not part of art college or science college or something like that? It's not it could be computer science, it could be math, right? The reason you end up in software engineering is because with engineering department is because somehow, see, world always figure out the right use for the people, right? And so the world figured out that what we really need is when people are writing and creating these computer programs, they want certain practices to be followed, right? There's a process to be implemented, and that process oriented thinking, process oriented doing the work comes out of engineering college, right? So those are the skills which are really taught, right? Honestly, writing that final piece of code which translates into machine code is probably the last job of the programmer or a software engineer, right? And what they really need to do is really to think logically in terms of, okay, I see cars moving on the road, and how do I translate them into a data structure mentally so that I can have computers and translate it into ones and zeros for the computer to understand, right?
So wait, I'm just giving in. I'm just saying that, look, I'm just going back to software engineers. For me, software engineers, very broadly speaking, 4 skills. This is my perspective. If you have a different dimension of looking at skills, please tell me.
With software engineering, I think what I feel is that there are a few abilities that you need. One is the ability to turn like desire described in English into some, logic that moves around. Like,
Fair.
oh, I want to click this button. Yeah, sure, you want. What then? Okay, that means that a button should appear there under your mouse somewhere, right? So people come with desires, and then your end users also come with desires. So like what those desires are, and how you can actually materialize those desires. Then there's the whole thing about juggling of trade-offs,
Okay.
which is like this one process of, like, let's say, hashing your password. Should we do it on the front end or on the back end? And which one is a trade-off with lower security? Which one is a trade-off with higher security?
Understood.
That
So doing
stuff like that.
something, as an example, doing something on the front end may be faster, but maybe less secure, or it may be
Yeah.
cheaper, but also maybe more expensive to maintain on the
Exactly.
server. Is things like that. Okay.
Exactly. So you do these trade-offs all the time. Like sometimes you're like, and the trade-off of Google putting things on memory is also a similar trade-off, right? And the thing that you traded off has to be solved separately. Like, what if the computer restarts and the memory is then gone? Like, how do you rebuild the cache of the search index on the servers which restarted? Because with hard disks, you did not have that problem. It is there on the hard disk, you rebuild from there. Now here, you will create a different solution. But for that point of availability, you figured that, okay, the trade-off is it goes to memory. Okay, so this juggling of trade-offs, because always like that, because it's always you are playing with a bunch of constraints, and you're figuring which constraint can I push and which one I am not yet hitting, so I can kind of eat into that side, and this is the constraint that I am actually hitting. Then the how computers work, and that is also very important, right?
Why?
That is important because you cannot optimize or you cannot even know these trade-offs unless you know how the computer works. Like, a lot of times, like, people have been talking about off late that this advent of React and making all these websites as single page applications. They initially were like, okay, these websites used to have different paths where fresh HTML is always fetched, and like React makes it faster that you transfer the JSON only, and then the front end is always built. But you kind of, like, a lot of people overdid it, and now these websites are less responsive because you're trying to do too much on the front end, and the front end is not that powerful. You can't have like a machine as powerful as your data center servers on the front end. And if you try to do way too much there, then it starts getting slower, and people are like, oh, these websites are like slow, sluggish, and everything is happening in React. Why does my computer download 10 MB of React to even show a hello world page in this website? All of that, right? So again, I think it fundamentally comes from understanding how the computer works. And when I say computer, I don't mean like your personal laptop only. I mean like how is the server working, how is the bytes being transferred, how does your laptop work, what is the difference in speed between read from the memory, from the cache, from the hard disk, like these order of 10 differences between various places where you read from. And that gives you your fundamental building blocks as to how you will design the system, like which parts you can read from a faster place, which parts you can read from a slower place. So how a computer works is very important. And I think the fourth thing, like if I was breaking it into four ways, these were three. And then the fourth thing is the syntax of the code itself. Because that is how you speak to the computer. That's how you nudge the computer to do what you wanted to do. And that's where syntax was very important. And then people had developed different syntaxes for different use cases. Like if you want to create an Android app, you had to understand Java, because people have developed this whole infrastructure where Java is the easiest way to make the Android work the way you do it, or Objective-C was the way to do it in let's say iOS or on Mac. And similarly, like if you have to do something on the browser, JavaScript was the only way. So you have to learn the syntax to a degree. This fourth skill, I think, is something that is reducing. Like if you draw this, that skill diagram, the pentagon.
It's called a 2x2. It's called a 2x2. We'll
Yeah,
do a 2x2.
it's a 2x2. Here it's, let's say, a 2x2 here. So I think the skill of the syntax itself, like being able to very precisely articulate to the computer what you want, is something that you can start doing a lot of it in English now. You don't need to articulate it in terms of software tokens, like and those were usually called tokens. Like today we call these things are tokens, like the LLM ones, but these are called tokens, right? Like the keyword is a token, the semicolon is a token, the brackets are token. Like in programming language, people who parse ASTs, they call that as tokens. So those tokens are that skill is starting to reduce now. You don't need that. So that's what I feel. Yeah.
Got it. I think yours is, sorry. I'll just say that Arnav's is actually slightly more elegant than it. Mine is also really cool, but Arnav's is very elegant. So I'll take Arnav's broad framework. Okay. 4 skills. I'm just taking it one more time. Number 1, you said, was the ability to translate a desire into something tangible, right? It could be a button, etc. Number 2, how do you manage trade-offs, which is, it could be any kind of trade-off with respect to security, with respect to time, with respect to cost, with respect to this. 2. 3, understanding how a computer works, broadly speaking. And number 4, syntax of, which is the language and the way in which you talk to something, either through a computer language, and how do you write that, etc. Broadly, these are the 4 skills. I think my next question is, okay, if assuming these are the 4 skills, can you give us a sense of what is an engineering pyramid in an, I guess, product organization, service, it could be service organization as well. What is important where? Let's say at the beginning of your career, because I'm again coming back to the first 5 years of a software engineer's career. What is the thing that matters the most for between these 4 skills that you talked about?
So when I talked about the 4 skills, I actually went top to bottom in that sense.
The most important to least important?
Not most important, least important. I think what happens is that like desire, then you go to trade-off, then how computers work, and then how you write the syntax. If you look at what does the CEO do, he does the first thing. Okay. What do you look at? The product managers in technical companies actually do the trade-off thing, right? Like your software architects and your senior engineers are doing the how computers work thing, and then your entry-level software engineers are doing the syntax thing. Let's say a company which is like selling software SaaS or doing deep tech. The CEO has not gotten there without doing the bottom 3 things actually. He started off his career with actually wrangling syntax, and then learned more about how computers work. Then he figured out that, okay, in the real world, trade-offs matter. And every layer you learn expertise in, you eventually learn how to get somebody else to do that for you. And you can elevate to concentrating most of your cognitive work on the next layer, like that. So now the CEO has figured out that, okay, my energy is best spent into figuring out which desires to satisfy, to go out into the world and find out what other desires exist in the world and create solutions for that. And of course, it will come with trade-offs. But I have hired some great, VPs and directors in product and tech who will take care of that. Like there's a famous exchange with Ken Kosianda and Steve Jobs about when they first made the iPod. He dropped it into his aquarium and bubbles came out of it. Yeah. And he said it means it can be smaller. He did not go to the shop floor and try to figure out where the compaction further can come. But he's like, what do people desire? People desire the smallest device to play audio from. And that's how the iPod, the what is it called? The iPod Shuffle, the smallest one, which was like a clip. You could put it on your. So it's there in Ken Kosianda's book about this. Like he talks about how Steve Jobs used to think.
By
And
the way, I always thought that story was apocryphal. I didn't know it was true.
no,
I mean,
that's actually, yeah.
I've heard that story, but I
Yeah.
thought it was apocryphal.
So it could be like, I mean, a bit of hyperbole there, but like he would tap into like people's desires, and then like he was not somebody known for going and writing the code, and he was not somebody known for going to the shop floor and finding out which gap you can reduce from the iPod. But he had the confidence that I have people in my org who can do this thing. Who, if I say that bubbles are coming out of my device, it means there is still some air pocket left and you can reduce. They will find out the correct trade-off. Right. So with software engineering, I think what is happening is like the ladder is being pulled out of the last layer, which, that's what happens. Like when you are starting off in the field of software engineering, that's what happens with most of us. When like what's like 5 lakh, 10 lakh is the number of people graduating with software engineering degree, or at least getting into software engineering space in India. Most of them work their way through into that field by that syntactical layer, because that's what most companies were hiring for, because that's where the pyramid gets formed. There's a lot of work to do in the syntax layer, because a lot of people are doing the top 3 layers and creating tons of jobs that, okay, now that we have figured out this is what people want, this is the trade-off, this is how we want to solve. Okay, now somebody has to translate it into code and actually write it.
Correct.
And there is a lot of code to write. There is 10 million lines of code to write. So we need to hire 100 people to do this thing. And that's where you started from. And like if you learned very fast, you learn the upper layers much faster. And if you did not, then you are like you're spending 4 years, 5 years doing this and slowly getting the other layers. So, and I've heard it from people who have gone into other fields as well. Like this, like in software, people often feel like straight out of college, people can start startups, and it happens sometimes that people. And I started my startup in college, so that's fine. But I think is like the career path. Let's say in mechanical engineering, how does it happen? Like you go to like I have my friend who went, I think, joined some place like Tata or Maruti, and they were on the assembly
Shop floor. Yeah, you're on the shop floor. You're on the assembly
floor.
line. Correct.
Yeah. And then it started off by like inspecting a component that's coming, whether it's correct. And there is some worker who was fitting it, and he was not the worker, but he was inspecting it. And if something was wrong, he would actually go wear his, blue overalls and actually fix it. That's where he started from. Like you don't become like, some designer of Aston Martin. Like, you don't do that happens straight out off the bat. Right. And a lot of these people, like the person who designed some of the flamboyant cars, like say the guy who designed, the XC9 car from Mahindra, he also I was listening to his podcast somewhere recently. I was like, yeah, I did start my journey from like the shop floor. And now like I am just designing the car on a piece of paper. And then, he's not thinking about the trade-offs. Like if I put my engine here, where will the petrol go and all of that stuff. He's not thinking about, he's just thinking that, okay, what kind of a car a person wants? They want a coupe back and all of that stuff. But that shop floor thing, as it gets automated, it does shrink the number of opportunities. So that definitely, I think, is happening, will happen a bit in the software world as well. Like the number of jobs of where the first 3 layers are done, and you just have to be hired to translate very technical specifications, not desires at that point, very technically written specification into code. And like in less savory words, people call this job as being a code monkey. So that is reducing to a degree, I think, because of this. So we'll have to start from probably the next rung in the ladder in some sense.
What I think is happening is, I think we are making a mistake of treating every software engineer as a fungible role. It's not true. What I'm trying to convey is that at the college level and at very early stages of your career, people are going to have to decide a specialization, right? The way a mobile engineer learns how to write mobile applications is very different from how a backend system engineer works in integrating various systems. I think every person has a different way of how their mind works, right? It's some people can visualize things mentally in an abstract manner much more easily, and other people are more they want to see something visual, right? And the way they operate is different. You cannot have one person, everybody at like on day one out of college is like, okay, I'm going to today work on backend systems, and 5 years down the line, I'm going to write great mobile application. That does not happen, right? What actually happens is people end up on one or the other thing by experiments 1-2 years down the line, and they realize, okay, I can visualize integrations between abstract concepts, so I can do backend more easily. Other people are like, no, I need visual feedback of what I'm doing, and so they try to write. So you end up with these specializations which were not present 20 years ago. And this is what I was talking about. The nature of our industry with maturity is changing. It's much more specialization based, right? The example Arnav is using of starting on the shop floor, this is apprenticeship, right? This is classic apprenticeship. Doctors go into hospital and for 5 years, they do residency, and then they figure out and they try various things within that residency. They'll try surgery, they'll try interacting with the patient's frontline, everything, right? They'll do all kinds of various visits. Some of them will go into research, right? So that's how, when you're talking about crores of people coming out of college, everybody cannot have the same path because everybody's made up different, right? And it's about the intellectual horsepower, but also within the intellectual horsepower, how their mind turns differently. Are they shape rotators in their mind or are they not, right? So that kind of individual feedback has to go in with experience. It's not just a random statement. All 1 million software engineers do this and you will have a career.
No. I mean, okay. I don't really agree, because what I'm really trying to understand is, you're right. We're not making broad generalities, or you're trying to create some kind of a loose framework. And of course, what you're saying is that, there are many paths for many people and everyone has their own strengths and every human being is unique, which we agree. There I agree.
Right.
But I'm just trying to figure out, here's the question now for both of you. Like now, if, as you say, Arnav, this bottom rung ladder is gone, as you say, you're basically saying, or at least like reduced a lot, where the stuff that you had to do syntactically, you can't do that anymore. So you don't get an opportunity to learn that to go up. Fine. I guess now we are coming to the heart of the question. What do you tell young people who are wanting to get into software engineering now? What should they do for their first 5 years now?
Yeah, I mean, it's both a hard question and an easy question. Because if you have to turn it into practice, then it's the hard one. But like if you just have to give gyan, then it is an easy question there.
Sure, let's start with the easy one. We are good at giving gyan. Let's do it.
Yeah. So the thing is, like, when I like my startup, which I started when I was in college, was actually around this thing, because I acutely felt like the college degree, even like a computer science degree, what is teaching you is not getting you job ready. And primarily because, like, if you want to like give a bunch of like lead code question answer and get into a large company, and not necessarily a FANG kind of company, but still a large company, like a large company which employs like hundreds of thousands of software engineers, then the CS degree is okay of a college. Like after that CS degree, you can still like solve a few algorithmic questions and land a job like that. And then in that job, the apprenticeship kind of happens. And some companies have formalized it. Like, like I think TCS or Infosys, they have that whole Mysore center where they like the 6 months of it's another college in that sense, right? But other companies like there are smaller companies, startups, and they want to hire. They had a lot of openings, and then people are like, okay, there is this bunch of startups coming out of Bangalore, out of Gurgaon, and they're hiring, and yet we don't know what they want us to do. And that's where was the pocket of opportunity. And me and my co-founder, we started the company. We were like, okay, we should learn while we are in college. Like, why wait for after college? While we are in college, in second year, third year, we should learn how to build a mobile app, how to host a website. Like after hosting the website, like in building the website, you have to create a domain, you have to set up the DNS, actually host it. And these skills nobody's teaching you in college, so you should learn a bit of that, right? And there are like when I used to sometimes interact with people who had not gone through this experience and they joined a very large company, and I'm like, okay, what do you do in the first 6 months? What do you do in the first 1 year? Might sound a bit, anyway, like I'll just go ahead and say it. It like felt like, okay, these people are doing a lot of fake work which is invented by their seniors there. Somebody has created a
This is
Jira
the
task for
classic
them.
David Graeber bullshit jobs, right? This is that kind
Yes,
of.
but also that's what they need to do the apprenticeship. Like they senior have created a task on Jira which says go to this website, click this button, and this will give you a new portal, and this is where you upload your code, and then you run this step. Like I would sometimes talk with them and I'm like, okay, the amount of effort is taken to assign you this task. Your senior could have done this task faster than you. Right. But then there is the model of work that happens in this company is that you need this influx of like every year 10,000 software engineers. Now, if you bring 10,000 software engineers and your like senior engineer, like your SDE2 level people, they can do the SDE1 work faster than the SDE ones who have been recently hired can anyway do. But they're still forced to invent this work for the SD1 layer so that they can learn and they can become SD2s eventually as well, and that's why it exists like that. But startups are under no such pressure to do that thing, and they're rather hiring somebody who, in the parlance of a large company, they already have SD 1 2 3 skills compressed into a single person, and they're like, come and let's just build things. Day one you actually write code to prod, right? So these compressions always happen like this only, and the one that's happening now is very similar, right? So today, if you want to get a job where you will mainly write code, you will open up an ID and you will actually write code. You will, hit character by character and write code. And you can't do the other thing. Like the person who tells you what code to write does not exist. That kind of job is gonna go away, So companies will hire people who will be like, who will generate a lot more amount of code because they can prompt their LLM. But they also have the ability to write the code, because when the LLM writes the wrong code, they can go down, dive into that function, and they can actually edit it. They can read the code first of all, and they can know it is wrong, and they can edit it and fix it. So it's like compression of the bottom two layers, which means that the hiring at an SDE1 level becomes with skills of SDE1 and 2 together, which means you need to know two things. You need to, rather than knowing just SDE1 level things, you need to know SDE2 level
Sorry,
things.
what is an SDE1 skill and what's an
those
SDE2
are
skill?
Seniority roles.
No, I know what they are, but then tell us what they
Praveen,
are.
Before we go there, right, I really want to question this, right? See, because we invented calculator, we did not stop teaching multiplication and division in school, right? That's not how it works, right? You have to teach them the basics. So programming is
I was not
something
asking
which
to
is
not
basic,
teach.
right?
Yeah, absolutely.
Right. So what I'm trying to tell you is that, look, imagine if you go back 500 years ago, right? People would be 10 or 11 years old and they'll get into their job, right? Because that's all the human knowledge there was. The schooling would end at age 10, 11, then you can go into the fields and start working on agriculture. What is happening with every century, if I may, that the amount of schooling, the amount of teaching we have to give students or children or young adults is increasing. You are looking at it from a very small perspective of within last 5 years, or there was a 4-year course, and now there's a lot more to be taught every year now. And it's becoming harder and harder to, there are fewer years where you're going to be productive in the long run. You're going to be like doctors. And that's why I keep going back to that the amount of knowledge which has to be given to an individual, like without computer architecture, you cannot understand operating systems. Without operating systems, you cannot understand applications. Without applications, you cannot understand prompt engineering. And so what I'm trying to convey is, at some stage, the world is going to come to a decision that engineering has to be a 6-year college, not a 4-year college or a 10-year college, just like it's. But some people, there will be pressure on them. They need to start earning because of family situation. So they'll exit at year 4, and that's when they are going to go and do basic work, what an MBBS does, because
I
cannot
shudder
be
to
MD
think
or
what
DM.
engineering college would be like for 10 years. It'll be like
It
some
will go down to
never-ending-
2, I feel. Like I strongly
Oh, wonderful.
feel
So
that
Arnav is
10 years
like 10, it seems. 2 years will be over. Okay.
No.
No,
but
it's
why do
very
you believe
simple.
that?
I'll
Tell
tell
us
you
that.
what will happen.
Huh.
Learning software engineering will be a 10-year journey.
Okay.
Sure. The degree will be 2 years. And people who can figure out the rest 8 years on their own will be accepted in the industry, and the industry will not have space for the others.
Oh, wonderful.
History
This is like
tells us
MBA
that's
now.
what it-
Okay, what?
Yeah, history tells us that's what happens. There are people who will today there are so many people who just learn how to use an ORM, and they.
What's an ORM?
Yeah, so an ORM is an object relational mapper. So you're writing code in, say, Java or JavaScript or C++, and you can describe your data schema in that language, and you connect it to a DB, and it will automatically create the corresponding tables and rows for you. So you create a class, it corresponds to a table. You create every field, it corresponds to columns there, and you save every object in your programming language. It automatically creates the SQL query to update it, right? There are so many people who just start production grade software engineering, not learning SQL or fundamentals of database, or what relational databases are, what a foreign key is, what a join is, normalization, a bunch of forms of normalization. People don't learn that. People get into it, and then eventually some people never learn it and they get fired from the job, and they go and do something else. They don't do software engineering. And there are people who are curious enough and they learn it on their own. And that is knowledge compression. That's how it works. What will happen is that people will do my version of the future is in 2 years you will learn prompt engineering, and then the wheat from the chaff will get separated. There will be people who will be curious enough, like, oh, what does my prompt actually create? I want to learn that code there. And they will go ahead in career. And then there will be people who will be like, I don't know, I asked ChatGPT, it does something for me, I don't know beyond that. And then they will exit that industry. Like, the industry is extremely cruel. That's how it happens.
Yeah. And this is the K-shape I was talking about. There are two different curves we are talking about. So what Arnav is talking about may be colored by his own experiences working with super smart people. There are a lot of people who can, this is how reality is.
I know you mean it in a good way.
Yeah, I mean it in a good way, because what happens is the bubble with AI is not just a financial bubble. It's a way all the smart people from excellent companies who have built these tools, they are looking at the world from a very narrow perspective of who they are, who their friends are, who their spouses are, who their colleagues are, right? The real world is very, very slow in adopting things, right? And very reluctant and lazy. Most people don't become IT engineers because they are excited by it, right? Most people become software engineers because it's a way for them to make money and then do what they really want to do, spend time with their friends, family, or whatever, right? These are the average performers. They get the ones Arnav was referring to as who don't take interest on how ORMs really work internally, right? So they can write an application with ORM, but they cannot write a SQL stored procedure because it's literally they are not curious about this. And these people are going to still have jobs because the super smart people, they are going to be very costly, right? Just look at the range of salaries in software industry, right? When everybody is just out of college, everybody, like in your 4th year of college, everybody is at zero salary. But year 1, so somebody is at, say, a top company, technically strong company, and they are like earning 7 lakhs, 8 lakhs, 10 lakhs a year. And then the weak ones are doing 2-3 lakhs a year. And you're like, okay, it's just 8 lakhs different. But 5 years down the line, the 2 lakh guy has moved to 3 lakh or 4 lakhs maximum. And this 10 lakh guy has gone to 1 crore salary, right? So this difference, this K-shaped process which happens with people, there's a large, and you have written about it, right? There are 10,000 engineers whom everybody's chasing. But these are the top companies. But the other 40 lakh are still employed, right? And they're still doing useful work. Somebody's paying them for it. So they're not in a government program guaranteed with a 10-year job. These guys are doing some useful work for the industry. And that useful work might be stuff which they cannot afford to hire somebody making 1 crore rupees a year for, right? So that's something what I'm trying to convey is that these people are never going to be replaced by prompt engineering because they're still there have always been open source software. Does it mean cloud services stop being used?
Yeah. I mean, no one is talking about engineering being replaced, but I'm again going to push the two of you to the same question. Fresh engineer in college, let's say, I mean, Arnav, you have done this again, not just at your startup, but also at Scalar. This is literally bread and butter for you. So what would you tell them to do?
Yeah. So I was going to complete my thought. So I think
finish.
When I take, like I was saying, like the entry levels of SDE1, when I was just saying that, you're translating very technically written things into code. And I think at a SDE2 level, where you're at least interacting with the product managers, you are understanding the architecture, you're seeing that, okay, where my data is stored, so I query it correctly and all of that stuff, right? So I think the entry level hiring will...
Sorry. Just for our listeners, you're basically saying SDE1 just writes code and there is no obligation for him or her.
Have to write code.
They've been told what they want to do and they just do it and they write it and they go home. They have no idea what
and in
else.
many companies, like probably not an Infosys kind of company, but still in fairly large company, like let's say even companies who have big India GDCs, like say a Walmart, a Target, a Bosch, Honeywell, these kind of companies. The SD1 generally comes with a cap on number of years. You have to upgrade from SD1 to SD2 within 2 years or 1 year. like that. Like there is an up or out kind of,
And what are the salary ranges for the SD ones at these kind of companies? Like, is it around the
it'll
7-10
probably
lakhs kind
be
of a
6-7
thing?
lakhs.
6-7 lakhs. Same what Saraf was also saying, right?
Yeah,
Okay,
it'll
fair
be between
enough.
6-7 lakhs, and an SD2 will be where you breach the 10 lakh barrier.
Fair.
Right. Now, there is already that, expectation from you that you do elevate from SD1 to 2 within 1 year or within 2 years or something like that. And if you don't do, then you are out in that sense. Because eventually the companies want just a pool of SD2. And the SD1s, they are like just an entry level thing. And I think that going ahead, what will happen is a bit of compression of these two roles will happen. Which means that you would be expected two things. One, how to still do 40 hours, 50 hours of SD1 level work, and plus do know the things that an SD2 is supposed to do, which automatically means you will need to use these AI tools to generate some of the code, save your time, so that the doing the SD1 level work by hand you are not doing anymore. And you also know a bit about the internals of the database, the network, the system. You can talk to a product manager and he tells you a requirement which is not very technically specified, but it's still like, okay, I want the user to be able to do this. So in your mind, you can think, okay, technically it means that this data needs to be transferred from this system to the other system to show this button here. Those things you can do. So you need the skills of both SD2 and 1, which means absolutely I agree with Abhay that it does not mean that the SD1 skills are obsolete. It's not that. It just means they are more compressed. You need to know this and that together. You get there. Right. And just like the ORM thing, what will happen is that because of ORMs, it's now possible for people to skip their SQL classes and land a job in tech. And then eventually, if you get curious, good for you. So now, again, with this, like, it will be possible to skip very strict syntax correctness as a habit. You can skip learning that because the LLMs can generate to a degree. Already your IDs were doing a lot of that, like with autocomplete and IntelliSense and all of these things. Syntax was not something like people are already saying, like in interviews, why are you asking about syntax? Like, will I ever have a problem in writing syntax in my production work? No.
Yeah,
my
if I
ID
don't have
will
the
give me a red
final
underline
curly
and I will
bracket, it will be like earlier
Exactly.
compilers would give errors and all. Now it's like it's never going to.
Yeah, my ID will give you a red underline and I will fix it. So why are you even testing me on syntax? But as less as 10 years back, testing people on syntax was extremely popular on job interviews of mass hiring and IT companies. Like making people write code on pen and paper and actually checking that the syntax was correct was happening. And by the way, this format of interviews were actually invented by Microsoft itself. So 35 years back, because they wanted people who would write kernel code, and you don't get a second chance with kernel code. It crashes in production. Like when they're building with like Windows 95, 98 back then. They want people who the IDs were not there back then. So good. Static code checking was not there. They wanted people who can write one shot syntactically correct code on a whiteboard. And that's where whiteboarding got invented. And in Microsoft today, whiteboarding is not really like, you don't need to evaluate people by whiteboarding for entry level Microsoft engineers to be good at their job, because even the Windows kernel today is being edited on an IDE. There is static code analysis and all of that is being done, right? But then, I mean, some super niche of people who get into abstract state tree parsing and compilers and languages, those kind of people will exist. There will be people who will invent new languages going ahead as well. So it's not like syntax as a research area will exist, but tripping people up on syntax just to hire entry level people has gone away. And similarly, like tripping people up on writing like a little larger abstraction, not a syntax, but okay, can you write a class? Can you write a for loop? These kind of things. You don't need to test that anymore because you just hire for people who can do that using the AI.
Got it. So the question now I have for both of you is that, look, for better or for worse, engineering colleges and or coding courses like an app tech, an IIT, etc. I'm just saying and or, okay, because I'm not 100% sure. For whatever, better or worse, have kind of been able to solve for the SD1 level. In other words, it's either these kind of places and or again the Infosys, Mysore campus, etc. essentially would be like, look, just go through this. At the end of it, you'll be able to write code with correct syntax and you can handle that. You can come into SD1 level, and then after that, it's like you're all in the water. Now, whoever can swim can swim. up or out, go to SD2, etc., etc. Survival of the fittest, for the lack of a better way of putting it. Are there currently institutions in the current setup that can, in your words, Arnav, if you're saying that the entry level now is you're expected to know up to an SD2 level, are the current institutions able to do that? And if they are not, what would you tell students? Again, I'm coming back to the same question, which is, what would you tell students to say, okay, now what do you do in order to get there? Previously, the playbook was very clear. Now, what do you do?
Even previously, I don't agree that the playbook was clear, right? See, SD was an extended interview, honestly, right? That's why there's a big pay jump from SD1 to SD2 at every single company, because they have hired you in a 1 hour, 2 hour, 5 hour interview, and they're not sure whether you have the skills to be a professional. It's not just about being able to write code, right? They're also checking whether you do your work, whether you show up on time. Passing an interview is not how you succeed in your career. You know, right? It's true for everything, right?
Sure.
See, one of the things I tell people is that most jobs, and I'm taking it in a slightly different direction, is I look at two things over here, right? Everything in life, I ask art versus craft, right? What is the art portion of it and what is the craft portion of it, right? What everybody, I believe, is arguing about with LLMs is that the craft is easier now, right? It's like, hey, you don't need to paint, you can take a picture of the landscape, right? You don't, like in the old times, you would go see a beautiful landscape and you'll capture it if you had the ability to craft. And now you have a camera in front of you when camera was invented, and then a digital camera which would do autofocus and things like that. So craft is becoming easier in some of these ways. And as I was saying, you're going through each generation of being more productive. But the art portion is no different. And I don't think that, I would say even the original learnings from whatever the industry has found in last 40-50 years in terms of how you should structure your systems, how they should interact, what are your backups, things like that, all of those skills still stay relevant. None of that goes away just because somebody else is writing the code for you, right? One of the things when you're talking about SD1 and SD2 and senior SD and then principal, what's really happening is if you just like close your eyes a bit, right? Like the principal engineer was always a prompt engineer, right? And the only thing which has happened to him is his coders are no longer carbon-based humans, but silicon-based agents, right? That's the difference, right? So the skill set to get to a principal has not changed, right? There's a famous story.
No. One second. Before you get to the story, I'm saying that may be true, but the point is that principal engineer has gotten there through the journey of being a carbon-based life form who has been doing these things and has eventually graduated to that point, right? So, Arnav, again for you.
Yeah.
So my point, one second. I'm getting to the two of you. I'm going to again push you. Tell us, what is your advice to people in college right now? Arsaraf, you cannot say,
No, I'm telling you.
Basics.
I'm telling you very basic. You have to do the basics. I told you, just because you have calculator does not mean you don't start with mathematics and.
So okay, fine. You're saying do the basics, continue doing what you're doing. Okay, Arnav,
right, because
tell us.
you invented calculus. Did you stop teaching mathematics from arithmetic? Like, it doesn't happen like that. It doesn't work like that. You just have to spend more years in school and college, or maybe a paid job, which is like an internship or apprenticeship. That's what I believe.
Fair.
It's not changing that much.
Okay. Arnav?
I have more radical views here.
Yes, I know it. That's why I'm asking you. Tell me.
So, one view on the fact that, when the knowledge compression happens, you have to compress the teaching also. You can't make people grind on the, fundamentals for long. You will have to skip through it a bit and let some people get curious in it and let the other people fall through the cracks. Okay. Sounds very cruel, but this is what will happen. Capitalistic pressure will make this happen.
Okay,
so let me just tell you that this is what will happen. So get prepared for this. Is what will happen. Like how much arithmetic do you do in your school, like by hand? In India, it's still very large, but still, at least in colleges, we have calculators now. But in the West, even in China, they don't do it that way. They do use calculators even in high school now. And then somebody who will become a mathematician, he will get curious on these things and he will learn. But you don't make people grind through hours of doing math by hand anymore. And that does not mean that good machine learning scientists are not getting produced. Like, I'm not even talking about Indians who have gone for masters in US. There are American born people going through that American system, and they're doing better than India in let's say the field of statistics, machine learning, all of these things. And their education systems already transformed a lot from India. They don't make people grind through arithmetic by hand like that anymore. They give people the tool, and then some people get more curious to do the thing that the tool is doing. Okay. So I don't think like, the make engineering 10 years kind of model is anyway going to work. Making it for 2 years is what will probably work. The other thing is we have to grapple with the reality that if there are, let's say, in a company pyramid where there are 10,000 SD1 people and there are 5,000 SD2 people, okay, and probably like there are some 200 principal engineers, right? These principal engineers needed this pyramid of 5,000 senior engineers and then 10,000 junior engineers below them to transform all the things that is coming into their head into reality. And now some of it will be done by GPUs, and then a big chunk of work where the cost is less than more than the cost, like the salaries are more than the cost of the running of the GPUs, the companies will shrink that headcount. It is gonna happen. There is no two ways out of it. Like you look at any of the large companies which employ more than 100K engineers, which includes even like the Amazons and Microsofts, and it also includes like the IT service companies and everybody. They have been shedding headcount like anything last 4 years.
That's correct.
Like, it's going down like anything. Like all of it is not AI. Some of it is because they overhired as well. But it is shedding, and this thing is not going to reverse here. And like ever since I've come to London, for example, I love going to historical engineering museums, and I see there was a time when railway engineering was at the top, like software engineering is today. Like, they will find statue of some guy, Brunel, statue of Andrew Stoddard, and, these people who are like, oh, this guy made the engine which went first time to Scotland. This guy made the engine with first time went from Thane to Mumbai and all of that stuff, right? This was like the peak, and everybody wanted to become a railway engineer. And when you say this guy made the engine, like, he also had his, set of apprentices around him and all of that. But today is like being a railway engineer, the thing that everybody aspires to be. And is railway engineering the industry which is driving the GDP of the country? It is not. It is just another thing that needs to happen. So software will also, to a degree, lose both its like pecking, like the point in the pecking order, and it will also lose headcount in that sense. So I don't think software engineering will continue to employ like an increasingly large number of people, because today it just does not employ a lot of people. It also used to add like 1 lakh more people into the headcount. I don't think that's going to happen. There is a large part of it at the entry level which the LLMs running on GPU can do. There will be people who will require an SD1 plus SD2 compressed, right? So now SD1 plus SD2 total people employed were 15,000, 10 plus 5. In the new world, you will require probably 8,000 people who know both these skills, and rest the GPUs are churning their wheels 24/7. So that will happen. That's the reality. I don't think we can escape that fact.
How will these 8,000 people, one second, how will these 8,000, let's talk about these 8,000 people. I'm assuming people who are in engineering college right now or who are managers right now are thinking of these 8,000 people, because for all practical purposes, that is now the entry level software engineer, right? Yeah. What does it take to become one of those 8,000 people today?
So the top line on the bottom line of this 8,000, how it will get cut is the top line is the people who are really interested in this thing itself, and they will do whatever it takes. People who stay up till 3 a.m. at night in college and they keep doing it, and even if you compress the teaching for them, they still expand it on their own and they read everything.
Got it. Bottom line, in a base world, they are the ones who learn the basics, who go deeper, etc., etc.
Yeah,
okay, fair enough.
Right. The bottom line would be people like, what is the point below which people can find alternative careers which will pay them more, and they will go. And then the cutoff will come to that point where people will be like, okay, this is better than any other alternative. So the top line is always, this is what I want, and the bottom line is always TI, and there is no other alternative. So that's where the cut will be. And the cut is very low level? Because this is better than a lot of other alternatives today, but this might not be better than a lot of other alternatives in the coming days. And it has happened in places. In Europe, there are a lot of countries where people actually recommend you to do vocational courses to become a plumber, to become an electrician, because those jobs pay a lot well, because they are not handyman style job anymore in these countries. There's extreme amount of regulations, very complex engineering works, like the way you do plumbing and electrical works in buildings here are extremely more complex than in India, where you just pull out a wire from the wall and you just tighten it. It's not like that. So they also are more complex pieces of work. There is dignity of labor for these kind of things. And so the cutoff point where you say that, okay, I would rather become a plumber than a software engineer, that cutoff point moves way up. You're like, okay, if I don't get a job for up to 10 lakhs, I would rather not do software engineering or do something else.
Okay, I'm going to close with a question for all three of you. Okay, and maybe all of us are qualified, not qualified to answer, but we'll try, right? If you had to give one piece of specific actionable advice, not about anything else. No, I mean, Saraf, you cannot say things like learn the basics. I mean, maybe that's actionable, but still, I'm trying to make it more actionable, where you say to students who are in engineering college, who are right now about to graduate or about to graduate, etc., what should they do? What should they actually do? Like, should they, I'm giving like broad examples, right? In order to make themselves much more to stand out in the middle of all of this, which is, should they go and do projects, live projects in company? Should they go and like vibe code stuff, create a website of their own? Should they like put stuff on GitHub and commits and all that? I don't know. I genuinely don't know what the old world was, and I don't know what the new world is. So I'm really asking, give actionable advice that people who can listen to this can basically wake up and say, okay, tomorrow onwards, I'm going to do this.
I'd say learn typing. That's the first thing I tell people. You have to start with the basics.
Okay, explain
Yeah,
why.
literally.
I mean, if we have already agreed that syntax is the thing
See,
that's going
it
to
doesn't matter if you're writing a prompt or you're writing C# code or Java code. You are going to be, if you're writing 40, like imagine somebody who's like, I do this. One of the tests we do for anybody we hire is have them write a typing test. And they type at like 20-25 words per minute with 80% accuracy. That's the general thing. And it's mandatory for them as part of their training to spend first 3 months doing daily typing practice. And you end up with about 60 words per minute. And there are two things which happens with that. They do touch typing, right? Where they're not looking at the keyboard when they're typing.
Correct.
And there are two aspects to this. One, you're spending less time writing whatever you're writing, whether it's email, documents, code, prompts, whatever you're doing it in half the time. So work that will take up 4 hours a day in typing will be done in 2 hours. That's a huge productivity boost for you. But more importantly, there's this concept of system 1 and system 2 thinking, right? Or when people start driving, they drive at like with system 1, they're aware of them driving. They are hitting the brakes consciously. They are changing the gears consciously, everything. But when you learn typing, touch typing, and it goes to system 2 where it's just your nature, what ends up happening is you're thinking more about the problem you're trying to solve on the screen. You're thinking about the email you're writing, not whether what's the next letter going to be. Your brain power is engaged in writing the actual content, the ideas into whatever you are typing, rather than thinking about that. And that's true for everything I was talking about through the internship. When these people start, and Arnav gave this example where he's talking about somebody who started at the shop floor and now they are designing, a super car. Because what has happened is, it's not that they have forgotten about engines and petrol lines and electrical lines and things like that. What ends up happening is it has become system 2 for them. It has gone to the back of the mind. But not having known the fund, it's to pretend for these peddlers of modern tools that the basics don't matter, because I'm doing something high level, simply because what has happened is with 10 years, 20 years of experience, those things have moved to system 2 in their thinking. It's still there. It's still being used. It's just that you're not actively thinking about it. And I just say,
I feel like I'm in a time machine. Okay, learn typing. Okay, that's interesting.
that's it.
But it's an interesting argument. Okay, I would argue though that
No, but it's an analogy. It's an analogy.
It's an analogy. I understand, but I would argue that voice is now becoming, like, especially people now are coding with voice. There are like
super whisper.
I mean, I don't know if Arnav's office is one of them, but there are like valley offices and startups where there are practically no keyboards and there is like a microphone at every desk. And
See, these are all stories you hear. I would challenge you to show me one case. Imagine 3 people sitting next to each other. How are you not fitting into each other? What's the noise cancellation?
That happens
story?
because there is something called super whisper, where you speak actually very quietly. And I have seen offices where people are actually doing that. They're using super whisper to actually
get a UK
prompt.
visa. Go and see.
It's faddy. It's faddy. People have to realize that it's a productivity increase. where are these startups who are like completely vibe coded and making millions of dollars unless they are just reselling chat GPT wrappers? I'm like, we have been talking about this for 3-4 years. Where's the proof in the pudding?
Okay, fine. We'll come to that. But okay, advice. Arnav, tell us.
I would say we are talking a lot about this rather than trying it out, and I think my advice to people would be to like open OpenAI docs and to make a API request to an LLM and get started there. Like,
Okay.
see how an LLM generates text. See how you create an agent by running a. It's very simple. It's a for loop through the LLM API call. It's not all that complex actually, right? See how you can automate generation of test cases in your code base using LLMs, right? Again, like these are things that, as of even today, out of the box, like something like Cloud Code does not do. Like, I mean, you can ask it to generate a test case one by one, right? But if you want, like, okay, every time I send a pull request, automatically it will generate a test case for what I had written. These kind of things. These are fairly low-hanging fruits, right? Start doing these things. It's like, when the internet came and cloud came, it was good advice to get a VPS SSH into it and try to run a website. When mobile came, it was good advice to try to make an app, even if it was just a ball bouncing app or just a hello world app. But it was good idea to do that. And I think it's just good idea to start seeing how these tools are how these
So you're basically
wrappers
saying-
are created. Like,
Yeah,
don't
you're
be a
basically saying
consumer who
thinker,
just
go under the hood is what you're really saying.
yeah. Don't just use chatgpt.com and use it like a consumer. If you want to be in the tech industry, that's my saying. Like, of course, if you're some other industry, sure, use it as a consumer. But go beyond using it as a consumer. Go beyond using it even as a power user. Go actually open the hood and look at how the engine is running a bit. I think that's something that we need to do. I think very few people do it. Like, I sometimes do these little workshops I announce on Twitter saying that, hey, we'll see. And then a lot of people don't even know how different coding agents we can use, and we can use one coding agent with a different model, how we can swap the model out for the coding, how we can use a local model for doing autocomplete so that you are not spending by the token to do that.
Correct.
So yeah, just start there.
By the way, I do want to add one thing. This is a problem which I've faced recently in last few months. People come to interviews. We do remote interviews all the time, and they just have another device with them, and they take whatever question we are giving to them, and they put it out in Chat GPT or whatever, and then they copy paste the code into the interview. They're sharing a screen, and we catch them very early, because when I ask them to explain what they have done, they cannot explain why a particular line of code was written. It's very evident that it's wrongly written. It was not the expected output, and it's just we obviously have to fail them because they're first of all cheating, but second of all, I can clearly see that even when they will get the productivity boost from LLMs, when the follow-up happens, which is how do you fix that, whatever has been wrong, they cannot do it, and that's not the expected behavior. So we are not asking people to learn the parameters being passed to a function, but being able to do what their job is a fundamental requirement, which is produce working code.
Rahel, advice?
Well, I am not well placed to give advice
No,
to
no,
it.
come on.
So to everyone else, I will say learn plumbing. But but actually, Abhay, you bring up a good point. And I mean, final question, I guess we can end with that. We were talking about the skills that you need, Arnav. You went into the depths of the kind of mindset, how you need to think about it. But how do you test for it? Like when you're hiring an entry level employee, what are those signs? I know you've done CV roasts in the past. I was hoping you could end with the opposite of that, right? Like if you're hiring an entry-level employee, the two of you today, how do you make sure they're part of the 8,000? It is a punt at the end of the day, but what are those signs that they're part of the 8,000 and not everyone else?
So for me, one thing is, if you look at my tweets, you will find it. I was allowing people to use Copilot and autocomplete agents and all back when in the early days of GeoCinema I was hiring, and this is more than 3 years back now. Okay. And that time, the majority opinion was that this is very early and we should not let people use it, because if they use it, we can't test what they're actually thinking. And I was like, no, this is the future, and I want to see how people embrace the future. I want to see how they prompt it. I want to see how they fix the bad code when they generate. So that's how I look at it. I feel like both the things, like the code that is generated, they should be able to understand what is generated and fix it themselves, and they should also have the this is like a takeoff of how people will code is happening. And people who have not embraced it, I would first of all fail those people as well. Like, if you cannot use the AI agents, if you don't know how to write code with it, or you are too prudent to work with them, that's strike 1, 2, 3 all for me together. Like, you're gone. Like, you want to be a dinosaur, no place to work with me in that sense, right? And then secondarily, exactly what Abhay is saying, like, of course, you should be able to explain what is happening. And this is happening. It's like a pair programming. Like, coding is now like a pair programming with an AI agent. So you need to have those skills. You need to be able to prompt the AI to generate the code, and then you need to have the ability to discern whether it is the correct thing that it generated or not. Like, the code that it generated is exactly what you had asked it to generate, and sometimes it is not. So quickly being able to catch it and then editing it either by reprompting or by just going out by hand and actually fixing it. That is very important. And I have always, I think in interviewing, I have always been ahead of the curve in that sense. Like, I have always also had, like, till my current job where I have to interview people in a very stringent format, the organization tells me to. But otherwise, I've always been in a place where either it was my own company or I was in senior leadership, so I could design how I was interviewing. And I always allowed people to use IDs. I always allowed people to use autocomplete. I had always allowed people to. There are a lot of people who are like, I don't want you to execute the code. You can only write the code, and we will interview based on it. And never like that. Like, you can execute the code. Yes, you can use Google. I have been allowing people to use Google for interviews for a long, long time, because that's how people work in production. And I want to see that, can you search the correct thing? Like, like, a lot of people, you can very clearly see that they're searching the wrong thing and going out into the absolute wild west, and then nowhere near the problem than they were before Googling. And that's a good signal for me that, hey, you don't even know how to Google the correct answer for this. So what's the point? So the way I look at it is, I'm always like, use the cutting edge of tools. You should be developing curiosity, and the younger people generally do it more than people who are established in the industry for a long time. So you are curious, you're using the new tools already, you have developed at least some way of working with those new tools, and I want to see that shine through.
Awesome. Abhay, what about you? What are you looking for in an entry-level hire?
Let me do this. Let me invert the question to you. So when you hire a journalist, are you going to ask them, let's say you say, can you write an essay for me? And if they give you a ChatGPT generated essay, what would you be looking for?
Well, that is a test we have internally, and we'd be, obviously we'd be put off by that.
Right, but it's the same thing, right? Whether the output being generated by LLM for a software how is that different from, say, an article? Like, I want you guys to talk about that as well. Seriously, I'm asking you guys.
No, I'm seriously saying that. I think from our standpoint, look, there are two ways to think about this. One way to think about it is that you can actually, you would like to believe that you can identify AI written text that is completely generated as opposed to human written text, because you can tell. Right. And of course, people say that, oh, no, you will stop being able to tell. Fair, maybe. But I think what's eventually going to happen is people are obviously going to crave. There is a certain emotion aspect to writing, which I don't think matters so much. It's not a clean analogy with the engineering side, because from the engineering side, it is about the code should work. Right. And if the code works, the code works. No one cares about whether the code makes me feel anything. Right. So I feel like the writing thing is a slightly different point. But I will say that from my standpoint, the thing that I will care a lot about, and I talk about from a product standpoint rather than a journalistic standpoint, would be that I always ask this question of whether it is an application, whether it is a product, whether it's anything else. The question is always about what was the another approach that you tried or considered but didn't do? Which is a very fundamental question, right? It's a very basic question. Again, I'm only talking to entry level. I'm not expecting like architects and high-level questions. It's a very simple question. Even to an entry-level engineer, I would ask this question. If I asked you to do this, you did this, you came to me and said, this is what I've done. I'm like, okay. What else did you consider? What other thing that you thought that you did not do? And that gives, at a very fundamental level, the thinking it reveals, right? That's really the question I ask.
And that's exactly what I do. I want to see what their brain went through, not what their companion GPT went through in their thinking process. And that's exactly what we do. That is when I'm hiring. I can't speak for the industry, but...
Fantastic. All right. Thank you, Arnav. Thank you, Abhay. Fantastic conversation. We would like to hopefully we'll use some of these things and changing hiring as well.
Hopefully
and the first
it
5
gets
years.
out soon enough and our answers are not obsolete by then, given the rate at which it is changing.
It's coming out in a
48
couple of
hours,
days.
but-
Yeah, 48 hours. So I think
But who
hopefully,
knows?
who knows? In 48 hours, let's hope it's relevant. But yeah, the way things are changing right now. But I will just say that for our listeners, please go check out Abhay and Arnav. Both of them are on X. They do put some really strong points of view, very interesting stuff. So I'd recommend if you just follow them, you'll get a bunch of like great ideas, thoughts, etc. All human generated.
Thank you. Thank you, Rahel. Thank you, PGK.
Thank you, guys.
Thank you.
Thank you for listening to this episode of 2x2. This episode was produced by Uddantika Kashyap and mixed by resident sound engineer Rajiv CN. If you feel there's something we've missed out in this discussion or feel some numbers or facts don't add up, you can write to us at 2bytwo@theken.com. And if you're listening to this episode on Apple Podcasts, please show us some love by leaving us a rating. Lastly, if you love the episode, share it with people, your friends, family, or colleagues who might find it insightful as well. We'll be back next week with an exciting discussion and a 2x2 for you to think about.